You know, we trust web apps with pretty much everything these days, right? Our money, our messages, all of it. But behind that screen, there's this constant, invisible battle going on. It's a race, really, a race to find the security bugs before the bad guys do. So today, we're diving into a new, much smarter way to win that race. Okay, let's kick things off with a number that's, well, it's pretty wild. Get this. Almost 78% of the top 10 million websites out there are all built on one single programming language, PHP. Now, that doesn't just make it popular, it makes it a gigantic uniform target for hackers. It's like they only have to learn one way to pick a lock to get into most of the houses on the block. And we're not talking about some small, random websites here. Oh, no. PHP is the engine running some of the biggest sites you use literally every day. Think Wikipedia. Think WordPress, which powers a huge chunk of the internet by itself. So when a bug pops up in PHP, man, the ripple effect is just enormous. The stakes for finding and fixing these things, they're as high as they get. Which brings us to the big, crucial question, right? With millions upon millions of lines of code powering all these sites, how on earth are developers supposed to find every single hidden flaw? I mean, how do you even begin to test something so complex, so widespread before it's, too late? Well, one of the go-to techniques for hunting bugs is something called fuzzing. It's a pretty simple idea, really. You just throw a whole bunch of random junk data at a program and see if you can make it crash. And for simple, standalone programs, it works like a charm. But for web apps, that's a whole different ballgame. It's a puzzle with some really, really tough pieces. So, challenge number one is the interface itself. Think of it this way. A web app is like a very picky person. It doesn't want to hear random gibberish. It expects you to speak its language, a very specific, structured language of key value pairs. Things like username equals Alex or password equals secret. Your typical fuzzer, it just doesn't speak that language. It's just shouting nonsense. And that combination lock analogy is perfect. Trying to fuzz a web app with random data is exactly like just spinning the dials on a combo lock and hoping for the best. I mean, what are the chances you're going to magically land on the right combination of keys and values to even get past the front door? Yeah, pretty much zero. All right, next big problem. Web apps have memory. They remember you. When you log in, they start a session. They're constantly talking to databases, changing files. Every single thing you do changes the state of the application. And that means every test you run could totally mess up the results of the very next test. It makes testing a complete nightmare. Seriously, just imagine you're trying to solve a maze, right? But every time you take a single step, the walls move and the whole layout changes. How could you ever map it out? Well, that's exactly what it's like trying to get reliable test results from a web app. And then there's the third challenge. And honestly, this might be the biggest one of all. It's about how these tools even know they've found a bug. See, traditional fuzzers are super simple. They're just looking for a crash. If the program crashes, bingo, you found a bug. But the most dangerous web bugs, things like SQL injection, they don't cause a crash at all. They're silent, which means the fuzzer is completely blind to them. Here's a great way to think about it. Imagine your bug hunting tool is a detective who only knows how to solve murders, a big, obvious, catastrophic event. They're an expert at that. But a super slick, silent bank heist happening right next door? Nope. They are totally oblivious. It's not on their radar at all. And that's the fundamental problem with using old-school fuzzing for the web. So, okay, we've got a complex interface, a state that's always changing, and bugs that are totally invisible to normal tools. It kind of sounds like fuzzing web apps is a lost cause, right? But what if it isn't? What if you could build a smarter bug hunter, one designed from the ground up to solve these exact problems? Well, let me introduce you to Atropos. This is the hero of our story today. It's a totally new kind of fuzzer, one that's been specifically built for the messy, complicated world of PHP web apps. And the key difference? It doesn't just blindly throw junk at the wall. It actually listens, it learns, and it adapts. So how does it pull this off? How does it tackle those three huge challenges we just talked about? Well, it's brilliant, really. First, for that complex interface problem, it uses what's called advanced feedback. It literally listens to the app to figure out the secret language of keys and values it needs to speak. Second, to deal with that whole stateful mess, it uses a magic reset button. No, really. It runs the app in a virtual machine, so after every single test, bam, it can hit reset and go back to a perfectly clean slate. And finally, to spot those silent but deadly bugs, it has custom sensors, specialized detectors that are built to find 8 different types of common web vulnerabilities, none of which cause a crash.
Okay, that all sounds great on paper, but this is where the rubber meets the road, right? How does it actually perform out in the wild? Well, the researchers pitted Outropos against the best tools available today to see if these smart ideas could actually deliver.
And the results? Well, to put it mildly, they're stunning. The official paper says it significantly outperforms the current state of the art. But here's the line that really made my jaw drop: not reporting a single false positive. Now, that might not sound like a big deal, but trust me, for developers, that is huge. We'll see why in just a second. Let's just look at the scoreboard, because the numbers really do speak for themselves. On a bunch of test applications that are known to be buggy, Atropos found 49 bugs. The next best tool, which just reads the code without running it, found 37. And the best of the traditional web scanners? It only found 7. This isn't just a little better. It's a completely different league. And that brings us back to this beautiful number: 0. That is how many false positives Atropos found. 0 wild goose chases. And this is why it's such a game changer. Developers waste so much time chasing down alerts from other tools that end up being nothing. Atropos just gives you the real deal: actual, verified bugs. Nothing else. But here's the ultimate test, right? Does it work on the real-world stuff, the apps we all use every day? You bet it does. During testing, Atropos found 7 brand new, previously unknown vulnerabilities in popular web applications. These are what we call 0 days. This proves Atropos isn't just a cool science project. It's a tool that can make a real difference in keeping us all safe online. So a tool like Atropos is obviously a huge step forward. But what does it mean for the big picture? Let's zoom out a bit and think about the future of web security as a whole. I think the main takeaway here is pretty clear. Finding these bugs is a straight-up arms race. As our web apps get more and more complex, the bugs get better at hiding. And that means our tools to protect them can't just be faster. They have to be smarter. They have to evolve right alongside the threats. And that leaves us with one last question to chew on. We're seeing these kinds of intelligent, automated tools being developed on both sides of the fight now. As the hackers get smarter and their tools get better, are these AI-driven defenders, systems like Atropos, are they our only real hope for staying one step ahead and actually building a safer web?